The year 1942 marked a period of unparalleled devastation across the Soviet Union. The German war machine, having launched Operation Barbarossa the previous summer, had carved a deep, bleeding wound into the heart of Russia. While the initial German blitzkrieg had been halted at the gates of Moscow, the Wehrmacht remained a terrifyingly efficient force, occupying vast swaths of territory from the Baltic Sea in the north to the Black Sea in the south. Inside these occupied territories, specifically within the dense woodlands of Belarus and Ukraine, a second war was raging. This was not a war of grand maneuvers and division-level tactics, but a brutal, intimate war of shadows, fought by the Soviet partisans. These partisans were a disparate collection of soldiers cut off from the retreating Red Army, escaped prisoners of war, and local civilians whose villages had been burned to the ground. They lived in the forests, striking at German supply lines, blowing up rail tracks, and ambushing convoys. To the Soviet high command in Moscow, the partisan movement was a critical strategic asset. If the partisans could strangle the German supply routes, the Nazi tanks on the front lines would run out of fuel and ammunition. However, the partisans face a catastrophic tactical disadvantage that bravery alone could not overcome. They were essentially light infantry, armed with little more than rifles, grenades, and stolen machine guns. Whenever the Germans decided to clear a forest sector, they would deploy armored units. Against a Panzer III or Panzer IV tank, a partisan in the rifle was helpless. The result was often a massacre. The desperate pleas radiating from the forests back to Moscow were consistent. The resistance needed heavy weapons. They needed anti-tank guns, artillery, and most importantly, their own armor. The psychological impact of a tank appearing in the middle of a guerrilla war could not be overstated. If the partisans had even a few light tanks, they could overrun German garrisons, destroy fortified checkpoints, and defend their forest bases against mechanized sweeps. But this demand created a logistical nightmare that seemed impossible to solve. How does an army transport a 6-ton combat vehicle hundreds of miles behind enemy lines through airspace dominated by the Luftwaffe and deliver it safely to a remote clearing without an airfield? The Soviet Union was not new to the concept of airborne warfare. In the decade leading up to the war, the Red Army had been the world's pioneer in paratrooper operations. They had established the VDV, the Airborne Corps, and had experimented with the doctrine of deep battle, which envisioned dropping thousands of troops behind enemy lines to sow chaos. But dropping men was a matter of simple physics. Dropping armored vehicles was a challenge that defied the engineering capabilities of the time. By 1942, the Soviet Air Force had already attempted a series of experiments to deliver armor by air, and almost all of them had ended in failure. The primary aircraft available for heavy transport was the Tupolev TB-3. This was a monstrous, 4-engine heavy bomber designed in the early 1930s. It was slow, cumbersome, and covered in corrugated metal skin, but it was the only aircraft in the Soviet inventory with the raw lifting power required for such tasks. In the early months of the war, engineers attempted to carry small scout tanks, like the T-27 or the amphibious T-37A, strapped underneath the belly of the TB-3 bombers. This method, known as the parasite configuration, was fraught with danger. The tanks were suspended on heavy bomb racks between the landing gear of the massive bomber. The problems with this method were immediate and severe. Because the tanks were carried externally, the immense drag created by the tanks significantly reduced the bomber's speed and range. The TB-3, already a slow target for German fighters, became a sitting duck. Furthermore, the tank crews often had to ride inside the tanks during the flight, exposed to the freezing slipstream at 10,000 feet with no heating and thin armor. The crews would often arrive at the drop zone suffering from frostbite and hypoxia before the battle even began. The delivery method itself was even more problematic. Since there were no heavy cargo parachutes reliable enough to lower a tank gently to the ground, the Soviets experimented with low-altitude, unpowered drops. The bomber would fly just a few meters above the ground at the slowest possible speed and simply release the tank. The theory was that the tank would hit the ground, roll to a stop, and be ready for action. In practice, the physics of a multi-ton metal object hitting the Earth at 80 miles per hour resulted in catastrophe. The suspension systems of the tanks would shatter upon impact, tracks would snap,
Engines would be knocked off their mounts, and transmissions would crack. The partisans would rush to the drop zone, only to find a pile of scrap metal that was useless for combat. Attempts were made to drop amphibious tanks into lakes or rivers to soften the impact. This, too, proved disastrous. If the angle of entry was not perfect, the tanks would skip across the water like stones, destroying their internal components, or they would simply sink like stones, drowning the crews trapped inside before they could open the hatches. The Soviet engineers realized that gravity was an enemy they could not defeat with brute force. They needed a way to make the tank land softly, with control and precision. The conversation naturally turned to gliders. The Germans were already developing massive cargo gliders like the Me-321 Gigant to transport heavy equipment. A glider could be towed to the target area, released, and piloted to a controlled landing in a field. It seemed like the logical solution. However, the Soviet aviation industry faced a critical shortage of resources. Building a fleet of giant heavy-lift gliders required aluminum, steel, and specialized manufacturing capabilities that were already stretched to the breaking point, producing fighters and bombers for the front lines. Moreover, there was the issue of what engineers called the dead-weight paradox. To build a glider capable of carrying a T-60 light tank inside its fuselage, you essentially had to build a massive aircraft around the tank. The glider needed a reinforced floor to support the tank's weight, a heavy landing gear system to absorb the landing, a cockpit, and a large fuselage structure. A glider capable of carrying a 6-ton tank might weigh 3 or 4 tons itself. This meant the towing aircraft, the tug, had to pull a combined weight of 10 tons. The TB-3 bombers simply did not have the engine power to tow that much weight at a safe altitude or speed. The drag and the weight would cause the engines to overheat and fail long before they reached the drop zone. The engineers were trapped in a cycle of failure. Parachutes were too complex and unreliable. Airdropping without parachutes destroyed the tanks. Heavy cargo gliders were too heavy for the available tow planes. The problem seemed unsolvable. They needed a glider that weighed nothing. They needed a delivery system that disappeared the moment it was no longer needed. They needed to eliminate the fuselage, the floor, and the cargo ramp. It was in this climate of impossible constraints that the Soviet military leadership turned to Oleg Konstantinovich Antonov. Antonov was a brilliant designer who specialized in gliders. He understood the subtleties of aerodynamics and lift better than perhaps anyone in the Soviet Union. When the request came from the People's Commissariat for Defense to find a way to deliver tanks to the partisans, Antonov looked at the problem through a different lens. He realized that the flaw in all previous attempts was treating the tank as cargo. As long as the tank was a passenger inside or under another vehicle, the weight penalty would be insurmountable. Antonov's radical idea was to stop treating the tank as cargo and start treating it as a component of the aircraft itself. He proposed a concept that sounded like madness to the traditionalists, the krylya tanka, or the tank wings. His proposal was to attach a set of removable biplane wings and a tail assembly directly to the hull of the tank. There would be no fuselage to hold the tank. The tank would be the fuselage. There would be no landing gear for the glider. The tank's tracks would be the landing gear. This design philosophy addressed every major failure of the previous experiments. By eliminating the cargo glider structure, they saved thousands of kilograms of weight. The towing aircraft would only have to pull the weight of the tank and the lightweight wooden wings. Once the tank landed, the wings could be jettisoned in minutes, leaving the tank fully operational and ready to fight. It was a solution of elegant simplicity, born from the harsh necessities of total war. The Soviet High Command approved the project, designating it the A-40. But moving from a concept on paper to a working prototype involved overcoming aerodynamic challenges that had never been tackled before. A tank is designed for ground warfare. It is built to deflect high-velocity armor-piercing shells. It is heavy, dense, and angular. Aerodynamically speaking, a tank is a brick. To make a brick fly, Antonov would need to design a wing structure of immense size and lift capacity. He would have to balance the center of gravity of a vehicle that was never meant to leave the ground. And he would have to do it quickly, because every day the project was delayed, more partisans were dying in the forests of Belarus.
The choice of the tank was the first critical decision. The standard T-34 medium tank was far too heavy. No wing structure could lift its 30 tons. The engineers settled on the T-60 Scout tank. The T-60 was a small, two-man tank armed with a 20mm autocannon. It weighed approximately 5.8 tons. It was not a juggernaut, but against infantry and light vehicles, it was lethal. If Antonov could get even a single T-60 into the hands of a partisan brigade, it could shift the balance of power in an entire sector. The design work began in earnest. The wings would be made of wood and canvas, materials that were cheap and non-strategic. The flight controls would be wired directly into the driver's compartment of the tank. The driver would not just be driving, he would be piloting a glider. He would need to control the ailerons and elevators using a modified set of controls installed next to the tank's steering levers. The line between tanker and pilot was about to be blurred in a way that had never happened in military history. As the winter of 1942 approached, the blueprints for the A-40 were finalized. The resulting machine looked like a creature from a fever dream, a grim steel war machine grafted onto the fragile wings of a biplane. It was a visual contradiction, a marriage of earth and sky that looked wrong from every angle. Yet the mathematics suggested it might just work. The engineers at the factory worked around the clock to assemble the prototype. They were building a one-way vehicle, a disposable aircraft designed to exist for only a single flight. However, as the prototype neared completion, a new problem emerged. Even with the lightweight wings, the T-60 was still pushing the absolute limits of what the TB-3 bomber could tow. To give the flying tank a fighting chance of getting airborne, the tank would have to be put on a diet. The engineers began stripping away everything that wasn't absolutely essential for the flight. They removed the fenders, the toolkits, and the spare tracks. But it wasn't enough. They had to go further. They drained the fuel tanks to the bare minimum required for the tank to drive off the landing field. They removed the ammunition. They even removed the main gun's firing mechanism. This stripping of the tank created a new operational paradox. The entire purpose of the flying tank was to deliver a combat-ready vehicle that could fight immediately upon landing. But to make the flight possible, they were turning the tank into a harmless steel box that would need to be refueled and rearmed by the partisans on the ground before it could fire a single shot. Despite these compromises, the project moved forward. The desperation of the war dictated that even a flawed solution was better than no solution at all. The flying tank was ready for its test flight, and a pilot had to be found who was brave enough or crazy enough to strap himself into a tank and be dragged into the sky.
The transition from a theoretical concept to a physical reality is often where military projects die. In the sterile environment of a design bureau, mathematics can be made to balance, but on the factory floor, the unforgiving nature of materials and physics takes over. For Oleg Antonov and his team, the task of building the A-40 was not simply an engineering challenge, it was a battle against the fundamental principles of flight. They were attempting to reverse engineer a machine designed for the ground to exist in the sky. The T-60 Scout tank, chosen as the fuselage for this experiment, was a vehicle built for traction, armor protection, and durability. It was, by definition, dense. Its job was to hug the Earth, yet Antonov's job was to make it float. The first hurdle was the sheer scale of the lifting surfaces required. To lift a 6-ton object that generated zero lift of its own, the wings had to be enormous. A monoplane design, a single set of wings like a modern airliner, would have required a wingspan so wide that it would have been structurally unstable and impossible to tow on standard runways. Antonov therefore reverted to the older, more robust biplane configuration. By stacking two wings on top of each other, he could double the surface area without extending the wingspan to unmanageable lengths. The resulting structure was a massive cradle of wood and fabric that dwarfed the small tank nestled beneath it. The wingspan stretched to 18 meters, and the total wing area was nearly 86 square meters. To put that in perspective, this was a glider with a wing area comparable to some medium bombers, yet it was carrying a payload denser than any bomb load. The construction materials reflected the desperate state of the Soviet economy. Strategic metals like aluminum were reserved exclusively for the production of frontline fighters like the Yak-1 or the Il-2 Stormovik. The A-40, considered an experimental project, had to be built from what was available: pine wood, plywood, and canvas. The juxtaposition was striking. The T-60 tank was a machine of cold, hard steel, riveted and welded to withstand machine gun fire. The wings attached to it were fragile, flammable, and almost primitive, reminiscent of aircraft from the First World War. It was a Frankenstein's monster of aviation, a hybrid creature that belonged to two different eras of technology simultaneously. The engineering team faced a unique problem regarding the controls. In a standard glider, the pilot sits in a glass cockpit with a clear view of the horizon and the towing aircraft. In the A-40, the pilot was the tank driver. He sat deep inside the armored hull of the T-60, peering out through a narrow, rectangular vision slit designed to protect him from shrapnel, not to offer visibility for landing an aircraft. The field of view was abysmal. To solve this, the engineers installed a rudimentary system of mirrors, similar to periscopes, to allow the driver to see the wings and the tow plane. The flight controls themselves were a marvel of improvisation. Cables were run from the wooden ailerons and elevators on the wings and tail down through the tank's turret hatch and into the driver's compartment. These cables were attached to a removable control stick clamped next to the tank's standard steering levers. The driver was tasked with a multitasking nightmare. He had to manage the tank's internal systems while simultaneously flying a glider that was heavy, sluggish, and unresponsive. The psychological pressure on the operator would be immense. He would be trapped in a steel box, suspended in the air by wooden struts, with no parachute and no way to bail out if the wings failed. As the prototype took shape, the most critical issue became weight. The math was unrelenting. The Tupolev TB-3, the designated towing aircraft, was an aging giant. Its four Mikulin M17 engines produced about 700 horsepower each, which was respectable in the early 1930s, but woefully inadequate for the heavy lift requirements of 1942. When the engineers calculated the total drag of the A-40, the resistance caused by the tank's unaerodynamic shape combined with the massive biplane wings, they realized the TB-3 would struggle to even get off the ground. The combined train of the bomber and the glider would be dangerously close to the stall speed. If the bomber slowed down too much, it would fall out of the sky. If it tried to fly too fast, the drag from the tank would tear the wings off. To give the project a fighting chance, the T-60 had to go on a radical diet. This process highlighted the central irony of the entire flying tank concept. The goal was to deliver a combat-ready vehicle to the partisans. However, to make the vehicle flyable, they had to strip away the very components that made it combat-ready. The engineers began by removing the fenders, the headlights, and the external storage boxes. These were minor weight savings. They then moved to the internal components. The radio was removed. The toolkits were taken out. The spare track links, usually bolted to the hull for field repairs, were discarded. Still, the calculations showed the glider was too heavy. The decision was made to drain the fuel tanks. The T-60 would carry only the absolute minimum amount of fuel required to start the engine upon landing and drive a few kilometers to cover. But the most controversial decision was the armament. A tank without ammunition is just a tractor. Yet every single artillery shell for the 20mm cannon added weight. The engineers unloaded the ammunition racks. They removed the magazines for the coaxial machine gun.
In a final act of weight-shedding desperation, they even removed the firing mechanism of the main gun itself, reasoning that the partisans could reinstall it upon delivery, assuming the partisans had the spare parts waiting for them in the forest. This stripping process created a tactical paradox known as the catch-22 of the A-40. The lighter the tank was, the safer the flight would be. But the lighter the tank was, the more useless it became as a weapon of war. They were building a delivery system that required the recipient to essentially reassemble the package before they could use it. If a flying tank landed and was immediately attacked by German forces, it would be defenseless. The crew would have to hide and wait for the partisans to bring fuel and ammo to them. Despite these obvious operational flaws, the momentum of the project was unstoppable. The Soviet leadership demanded innovation, and Antonov was delivering it, regardless of the practicality. By late August 1942, the prototype was ready. It sat on the tarmac at the Flight Research Institute near Moscow, looking like a surrealist sculpture. The massive twin-boom tail extended far behind the tank, and the wooden wings cast a long shadow over the steel hull. The mechanism for detaching the wings was tested repeatedly. It relied on a single lever inside the tank that would actuate a release cam, severing the connection points. If this mechanism jammed upon landing, the tank would be stuck carrying an 18-meter wooden dillboard on its back, making it impossible to maneuver through a forest or hide from enemy aircraft. The success or failure of the project now rested on the shoulders of one man. The test pilot selected for this suicide mission was Sergei Anokhin. Anokhin was a legend in the Soviet aviation community, a man whose reputation for fearlessness bordered on mythology. He was an experimental test pilot who had already survived numerous crashes. Most notably, he had lost his left eye in a previous accident, yet he had convinced the medical boards to let him keep flying. He was a cyclops in the cockpit, relying on monocular vision to judge depth and distance, skills that were critical for landing a glider. Anokhin didn't just pilot, he was a master of gliders. He had flown the rotocopter gliders and other experimental designs that most pilots refused to touch. When he approached the A-40, he didn't see a death trap, he saw a challenge. He spent hours inside the cramped T-60 hull, familiarizing himself with the strange hybrid controls. He practiced the sequence, checking the tow cable tension through the periscope, adjusting the trim, and rehearsing the emergency release procedures. He knew that the TB-3 towing him would be pushed to its mechanical limit. He also knew that if the aerodynamics were slightly off, the tank could flip upside down in midair. In a normal plane, you can bail out. In a tank, the hatch is on top. If the tank flips, the hatch is blocked. There would be no escape. The date was set for September 2nd, 1942. The location was the Tumen airfield in Siberia, far away from the prying eyes of German reconnaissance planes and the immediate dangers of the front line. The weather was clear, with a light breeze, optimal conditions for a glider test. The ground crew hooked the heavy steel tow cable to the rear of the TB-3 bomber and the nose of the flying tank. The cable lay slack on the concrete runway, a steel umbilical cord connecting the old giant to the new experiment.
As Anokhin climbed into the T-60, he wasn't wearing a pilot's flight suit. He was wearing the padded canvas helmet of a tank driver. The absurdity of the image was not lost on the observers. A tank driver preparing for takeoff. He squeezed into the driver's seat, the smell of oil and cold steel surrounding him. He checked the mirrors. The wings shook slightly in the wind. The wooden frame creaked. Ahead of him, the four engines of the TB-3 roared to life, spitting smoke and flames as they warmed up.
The noise was deafening, vibrating through the armor of the tank. The pilot of the TB3, Pavel Eremiev, signaled that he was ready. He pushed the throttles forward. The bomber began to roll. Anokhin gripped the control stick with one hand and the tank's steering lever with the other. The slack in the cable was taken up with a violent jerk that shuddered through the tank's hull. The wheels of the bomber and the tracks of the tank began to spin. They were accelerating. The experiment was no longer a theory. The flying tank was hurtling down the runway, about to defy gravity or punish the hubris of its creators. The engineers held their breath. In a few seconds, they would know if they had built a weapon of victory or a flying coffin. On the morning of September 2, 1942, the runway at the Flight Test Institute became the stage for one of the most surreal spectacles of the Second World War. The setup defied all conventional logic of aviation. At the head of the formation sat the Tupolev TB3, a four-engine bomber that had been the pride of the Soviet Air Force a decade earlier, but was now showing its age. Its corrugated metal skin vibrated as the four Mikulin M17 engines revved to maximum power, generating a deafening roar that echoed across the airfield. Behind it, connected by 100 meters of steel cable, crouched the T-60 tank. With its massive wooden biplane wings extending 18 meters outward, it looked less like a weapon of war and more like a confused insect, a beetle trying to masquerade as a butterfly. Inside the tank, test pilot Sergei Anokhin sat in a cramped dark world of steel. Unlike a conventional cockpit, where a pilot is surrounded by glass and sky, Anokhin was encased in armor plate. His view of the world was restricted to the narrow driver's vision slit and the hastily installed periscope mirrors. The sensory experience was unique and terrifying. As the bomber began its takeoff roll, Anokhin didn't feel the smooth acceleration of pneumatic tires on concrete. He felt the grinding metallic vibration of steel tracks biting into the runway. The tank was not rolling, it was clattering. The friction generated by the tracks was immense, acting as a brake that the bomber had to overcome with raw horsepower. The TB3 lumbered forward, gathering speed agonizingly slowly. The pilots and the bomber pushed their throttles past the red line. The engine screamed, burning rich fuel mixtures to squeeze every ounce of thrust from the pistons. Slowly, the aerodynamic forces began to take hold. The massive wings on the tank began to generate lift. The suspension of the T-60 decompressed as the weight of the vehicle shifted from the tracks to the wings. Then, with a lurch that shuddered through the tow cable, the tank left the ground. For the first time in history, a main battle tank was airborne. However, the moment the tank left the runway, the physics of the situation turned hostile. As long as the tank was on the ground, the resistance was mostly rolling friction. Once it was in the air, the resistance became aerodynamic drag, and the A-40 was an aerodynamic nightmare. The tank's hull was a collection of flat surfaces, sharp angles, and rivets, all of which churned the air into a turbulent, chaotic wake. The turret, protruding into the slipstream, acted like a massive air brake. The biplane winds, while providing lift, also added their own significant drag profile. The TB3 bomber, already struggling with the sheer weight of the tow, hit what engineers call the drag wall. The combination of the heavy bomber and the unaerodynamic glider created a total drag coefficient that exceeded the power output of the engines. The formation began to climb, but the rate of ascent was pitiful. They clawed their way into the sky, meter by meter. The trees at the end of the runway passed uncomfortably close beneath the tank's tracks. As they reached an altitude of 40 meters, the situation in the towing aircraft went from difficult to critical. The pilot of the TB3, Pavel Yeremiev, watched his instrument panel with growing horror. The water temperature gauges for the engines were spiking. The needles swung deep into the danger zone. The engines were overheating rapidly. The immense strain of pulling the flying tank was cooking the bomber's power plants. If the engine seized, the bomber would stall and crash, killing everyone on board and destroying the prototype.
Yeremyev tried to shallow the climb to gain speed and cool the engines, but the drag was relentless. The A-40 was acting like a giant anchor dragging through the sky. The bomber began to shudder, buffeting in the turbulent air. They were barely moving at 130 kilometers per hour, perilously close to the stall speed for such a heavy configuration. The test plan had called for a release at a high altitude, perhaps several thousand meters, to give Anokhin time to test the glide characteristics and maneuver. But they hadn't even reached the height of a small skyscraper, and the mission was already falling apart. The decision had to be made in seconds. Yeremyev realized that the experiment had failed. The TB-3 simply did not have the power to tow the A-40 to the target altitude. The choice was stark: release the tank now and save the bomber, or hold on and crash both aircraft into the forest. Yeremyev shouted the command. The release mechanism was triggered. With a metallic twang that resonated through the tank's hull, the tow cable detached. Suddenly, the roar of the bomber's engines faded into the distance. Sergei Anokhin was alone. He was floating in a 6-ton tank just above the treetops with no engine power to keep him airborne. The silence was absolute, broken only by the rushing wind whistling over the armor plating and the creaking of the wooden wing spars. This was the moment of truth. If the A-40 was unstable, it would pitch up and stall or roll over and plummet like a stone. But Anokhin was a master pilot. Despite the terrifying absurdity of his vehicle, he remained ice cold. He gripped the control stick, fighting the sluggish response of the ailerons. To his surprise, the tank was actually flying. It was heavy, it sank rapidly, but it was stable. The massive wings were doing their job. The tank glided with the grace of a falling brick, but it was a controlled fall. Anokhin quickly scanned the terrain through his limited viewport. He had no altitude to play with. He couldn't circle around to line up with the runway perfectly. He had to find a landing spot immediately. He spotted a rough field adjacent to the Bukovo airfield. It wasn't a paved runway, but it was flat enough. He nosed the tank down to maintain airspeed, the ground rushing up to meet him at a terrifying pace. Landing a glider is always a one-shot deal. You cannot go around for a second try. Landing a tank glider was infinitely more dangerous. A normal aircraft has shock-absorbing landing gear with rubber tires designed to cushion the impact. The T-60 had steel tracks and a torsion bar suspension designed for crossing ditches, not for falling out of the sky at 100 kilometers per hour. If he came in too steep, the impact would break the pilot's back or shatter the hull. If he came in too fast, the friction of the tracks hitting the dirt could flip the tank end over end. Anokhin flared the tank just meters above the grass, pulling back on the stick to bleed off speed. The A-40 settled onto the earth. The touchdown was violent. The steel tracks slammed into the soil, kicking up a massive cloud of dust and dirt. The tank shuddered violently as it skidded across the field, the suspension groaning under the impact force. But it didn't flip. It didn't break apart. The wooden wings flexed and rattled, but they held. The tank rolled for several dozen meters, the friction of the earth acting as a powerful brake, before finally coming to a halt. Anokhin sat there for a moment, the adrenaline pumping through his veins. He was alive. He had just successfully landed a tank. He wasted no time. He reached for the lever that controlled the wing release mechanism. This was the second part of the test. Could the tank transition from aircraft to combat vehicle instantly? He pulled the handle. The locking pins retracted. The massive wooden wing structure, now just dead weight, detached from the hull and fell to the ground alongside the tail booms. Anokhin engaged the clutch and hit the starter button for the T-60's engine. The gasoline engine coughed to life. He shifted into gear. The tank lurched forward, leaving its wings behind in the grass like a discarded cocoon. He drove the tank off the field and toward the airfield's command post. The sight that greeted the airfield personnel was hallucination-inducing. The officers and guards at the Bukovo airfield had not been fully briefed on the secret test. They saw a TB-3 bomber land, clearly in distress with overheating engines, and then moments later, they saw a T-60 tank emerge from the grass at the edge of the airfield and drive casually onto the tarmac. The base alarm began to ring. Soldiers scrambled for their weapons. A tank had just appeared out of nowhere, deep inside Soviet territory, miles from the front lines. Was it a German infiltration? Had the Nazis dropped a Panzer unit behind the lines? The guards surrounded the vehicle, rifles raised, shouting for the driver to surrender.
Anokhin stopped the tank and popped the hatch. He climbed out, still wearing his padded tanker's helmet, and calmly explained to the bewildered security team that he hadn't driven there from the front line. He had flown there. It took several minutes and the intervention of the test program officers to convince the guards that this was a Soviet experiment and not a German invasion. The flight was technically a success. The A-40 had flown, it had glided, and it had landed safely. Anokhin had proven that the aerodynamics were sound, or at least survivable. But the premature release of the tow cable told a different story. The test had exposed a fatal flaw in the concept, one that had nothing to do with the tank and everything to do with the limitations of Soviet aviation power. The flying tank worked as a glider, but as a cargo, it was simply too heavy for the existing fleet of bombers to handle. As the engineers inspected the tank and the abandoned wings in the field, the reality set in. They had built a glider that no plane could tow to a combat altitude. They had created a weapon that required a delivery system that didn't exist. The euphoria of the safe landing was quickly replaced by the cold, hard calculations of logistics. The A-40 had survived its first flight, but the project was already dying. The dream of raining tanks upon the Nazis was about to crash into the hard wall of industrial reality. The dust had settled on the airfield at Bykovo. The adrenaline of the landing had faded, replaced by the cold, sterile light of analysis. Sergei Anokhin had done the impossible. He had piloted a tank through the air and returned it to the ground intact. In the immediate aftermath, there was a brief flicker of hope among the design team. Technically, the concept had been proven. The aerodynamics held up. The control surfaces worked. The wing release mechanism functioned as designed. Under the strict definition of the engineering parameters, the A-40 was a functional aircraft. However, in the unforgiving calculus of total war, technical success does not always equate to operational viability. As the reports were compiled and the flight data was analyzed, the initial euphoria evaporated, revealing the stark reality that the project was a strategic failure. The primary culprit was not the tank nor the wings, but the towing aircraft. The test flight had exposed a critical weakness in the Soviet aviation inventory that could not be easily fixed. The Tupolev TB-3, the workhorse of the early war years, was simply too weak. During the test, the bomber's engines had been pushed to their breaking point. The water temperature gauges had redlined almost immediately after takeoff, and the pilot had been forced to release the glider prematurely to avoid a catastrophic engine seizure. This was not a minor mechanical hiccup. It was a fundamental incompatibility of physics. The drag coefficient of the winged tank was so immense that towing it required an amount of thrust that the TB-3 simply could not generate. The engineers ran the numbers again. To tow the A-40 to a combat-effective altitude of 2,000 or 3,000 meters, heights necessary to glide deep behind enemy lines, would require a towing speed of at least 160 kilometers per hour. The TB-3 struggled to maintain 130 kilometers per hour at treetop level. If they continued to use the TB-3, the range of the flying tank would be negligible. It would be a short hop from the front line to the first line of trees, hardly the deep strike capability the partisans needed. There was, theoretically, an alternative. The Soviet Air Force possessed a more modern, more powerful heavy bomber, the Petlyakov PE-8. This four-engine beast was the Soviet equivalent of the American B-17 Flying Fortress or the British Lancaster. It had modern engines, high-altitude performance, and the raw power to potentially tow the A-40 at the required speeds. For a moment, the solution seemed obvious. Simply switch the tow plane. But this proposal crashed headfirst into the wall of strategic priorities.
The PE-8 was a rare bird. Unlike the thousands of T-34 tanks rolling off the assembly lines, the PE-8 was difficult and expensive to produce. By 1942, only a handful, fewer than 90 in total, had been built. These aircraft were precious strategic assets, reserved for high-priority bombing missions against Berlin, Königsberg, and German rail hubs. The Soviet High Command, specifically Stalin himself, viewed these bombers as the long arm of Soviet vengeance. To divert these scarce, high-value strategic bombers to serve as tugboats for light tanks was a non-starter. The risk of losing a PE-8 to German fighters while it was flying low and slow, tethered to a tank, was unacceptable. The cost-benefit analysis was brutal, risking an irreplaceable heavy bomber to deliver a replaceable light tank was bad math. Beyond the aviation issues, the operational paradox of the A-40 began to look increasingly insurmountable. The test flight had proven that to get the tank airborne, it had to be stripped to the bone. This requirement turned the weapon into a liability. Imagine the scenario on the ground. The tank glides silently into a forest clearing behind German lines. It lands successfully, but now it is sitting there with no fuel, no ammunition, and no secondary machine guns. It is a paper tiger. For this tank to become a weapon, a complex logistical dance would have to occur immediately upon landing. The partisans, hiding in the woods, would have to rush out with jerry cans of gasoline to refuel the tank. They would have to haul crates of heavy 20mm cannon shells and belts of machine gun ammunition. They would have to reinstall the firing mechanisms and load the racks. All of this takes time. Precious minutes, perhaps hours, and this activity would be happening in a landing zone that had likely just attracted the attention of every German observation post within 10 miles. A landing glider is not silent upon impact. The crash of the tracks and the dust cloud are visible and audible signatures. If a German patrol arrived while the partisans were still refueling, the flying tank would be nothing more than a stationary target. It couldn't fire back, it couldn't maneuver, it would be destroyed before it fired a single shot. The entire concept relied on a perfect, uninterrupted reception by the partisans, a luxury that rarely existed in the chaos of guerrilla warfare. Furthermore, there was the human factor. Sergei Anokhin was an elite test pilot, a man with supernatural reflexes and thousands of hours of flight time. He had struggled to keep the A-40 stable. To make this project operational, the Red Army would need to train hundreds of drivers to replicate Anokhin's feat. But who would these pilots be? You can't take a tank driver, whose training consists of pulling levers and reading a compass, and turn him into a glider pilot capable of dead-stick landings in a few weeks. Conversely, you can't take a pilot and train him to be an effective tank commander overnight. The training bottleneck would be massive. In the middle of a war for survival, the Soviet Union did not have the time or resources to establish a specialized flying tank school. The report that landed on the desk of the People's Commissariat for Defense was damning. It praised Antonov's ingenuity and Anokhin's bravery, but its conclusion was cold and final. The project consumed too many resources for too little gain. The aerodynamic drag was too high. The towing requirements were too steep. The operational capability upon landing was non-existent. The A-40 was labeled an interesting but impractical experiment. It's worth noting that other nations faced similar problems but found different solutions, highlighting why the Soviet approach was a dead end. The British, preparing for the invasion of Europe, developed the Hamilcar glider. Unlike the A-40, the Hamilcar was a massive, purpose-built aircraft that carried a Tetrarch light tank inside its fuselage. This distinction was crucial. Because the tank was cargo, it didn't need to be stripped. It flew fully fueled and fully loaded with ammunition. The tank crew sat inside the tank during the flight, engines warm, listening to the intercom. As soon as the Hamilcar touched down, the nose of the glider swung open and the tank drove out, firing. The British accepted the dead weight of the glider's structure because it ensured the tank was 100% combat ready the second the wheels touched the dirt. The Soviets, in their attempt to save weight by making the tank fly, had inadvertently stripped the tank of its purpose. By 1943, the strategic situation on the Eastern Front had shifted dramatically. The desperation that had birthed the A-40 was fading. The Red Army had encircled the Germans at Stalingrad. The factories behind the Urals were churning out T-34s by the thousands. The Soviet Union was no longer fighting a desperate defensive war. It was beginning the long, bloody march to Berlin. The need for guerrilla gadgets and trick weapons was replaced by the need for brute force and mass production. The partisans were still fighting, but the Red Army was coming to relieve them, not by air, but by crushing the Wehrmacht on the ground.
The A-40 prototype was abandoned. The wooden wings were likely dismantled for firewood or left to rot at the edge of the airfield. The T-60 tank used in the test was returned to its original configuration, armor bolted back on, gun reinstalled, and likely sent to the front lines to meet its fate like thousands of other tanks. The project was officially canceled. In February 1943, there would be no fleet of flying tanks darkening the skies over Ukraine. However, the legacy of the project lingered in the minds of the engineers. It stood as a testament to a specific moment in history, a moment when the boundaries of what was considered possible were stretched by the terrifying necessity of survival. It was a failure, yes, but it was a magnificent failure. It proved that the Soviet engineers were willing to try absolutely anything to defeat the invader. But the story doesn't quite end with the cancellation. While the A-40 never saw combat, the technology and the audacity behind it influenced Soviet aviation design for decades to come. The idea of heavy lift transport, of moving massive amounts of armor by air, became a cornerstone of Soviet military doctrine during the Cold War. The A-40 was the grandfather of the massive Antonov transport planes that would eventually carry main battle tanks inside their bellies. The dream of the flying tank didn't die, it just evolved. Instead of putting wings on the tank, they eventually learned to build a plane big enough to swallow the tank whole. As we look back at the grainy photographs of the T-60 with its biplane wings, we see more than just a weird military curio. We see the desperation of 1942 frozen in time. We see a machine that shouldn't have existed, flown by a man who shouldn't have survived, in a war that demanded the impossible. The A-40 was a technological dead end, but it remains one of the most fascinating what-ifs of the 20th century. The Antonov A-40 flying tank is often cited as a singular example of Soviet desperation, a unique folly born from the specific horrors of the Eastern Front. However, to view it in isolation is to miss a broader, stranger truth about the Second World War. The obsession with airborne mechanization was not a uniquely Russian fever. It was a global contagion. Across the world, Allied and Axis engineers alike were wrestling with the exact same physics problems, often coming up with solutions that were just as bizarre, if not more so, than Oleg Antonov's biplane tank. In Great Britain, an Austrian refugee and aviation pioneer named Raoul Hofner was working on a project that rivaled the A-40 in sheer absurdity. While Antonov was welding wings to a T-60 tank, Hofner was attaching a helicopter rotor to a Willys Jeep. This project, known as the Hofner Rota Buggy or the Blitz Buggy, was born from the same tactical necessity, giving airborne troops immediate mobility upon landing. The logic of the Rota Buggy differed slightly from the A-40. Instead of a fixed-wing glider, Hofner opted for an autogyro design. A massive, free-spinning rotor was attached to the roof of a standard Army Jeep, and a tail fairing was added for stability. Like the A-40, it had to be towed into the air by a bomber. The theory was that the rotor would generate lift as the Jeep was pulled through the air, and upon release, it would auto-rotate gently to the ground. The test flights of the Rota Buggy were terrifying spectacles. During early towing tests behind a Whitley bomber, the flying Jeep exhibited violent vibrations. The pilot had to wrestle with a control column that shook so hard it threatened to break his arms. Yet, incredibly, it worked. The rotobuggy flew at speeds of up to 113 kilometers per hour and successfully landed. However, much like the A-40, it was doomed by the arrival of purpose-built heavy gliders. The British realized that it was simply safer and more efficient to park a Jeep inside a Horsa glider than to try and turn the Jeep into a helicopter. Meanwhile, on the other side of the world, Imperial Japan was conducting its own secret experiments with flying armor. The Japanese army developed the special No. 3 light tank, also known as the Ku-ro. This project bore a striking resemblance to the Soviet A-40. It involved a specially designed light tank that weighed around 3 tons, fitted with detachable wings and a tail empennage. The Japanese design was, in some ways, even more radical than the Soviet one. The Ku-ro was not a modified existing tank. It was built from scratch specifically to fly. It featured a streamlined, aerodynamic hull that looked more like a cockpit than a tank turret. However, the Japanese project suffered from the same fatal flaw as the Soviet one: the lack of a tow plane powerful enough to haul it up. While prototypes were built, there is no confirmed record of the Ku-ro ever achieving flight. It remained a paper dragon, destroyed or lost in the chaos of Japan's surrender. These international comparisons highlight a crucial point. The Antonov A-40 was not a failure of imagination, it was a failure of propulsion technology. It stands out in history because, unlike the Japanese Ku-ro, which never flew, and the British rotobuggy, which was a soft-skinned Jeep, the A-40 was the only true tank, a tracked, armored combat vehicle to successfully take to the skies and return to Earth. It remains the only time in human history that a tank commander has logged flight time as a pilot in command. But the story of the Soviet flying tank did not end with the scrapping of the A-40. The dream of deep battle, of dropping heavy armor behind enemy lines, was burned into the DNA of the Soviet military doctrine. The failure of the A-40 didn't kill the dream. It simply forced the engineers to find a different solution. As the Cold War froze relations between East and West, the Soviet Union formed the VDV, the Airborne Forces, the largest paratrooper force the world had ever seen. The ghost of the A-40 haunted their design bureaus. They knew that in a nuclear war, paratroopers would need protection from radiation and shrapnel immediately upon landing. They couldn't walk to the battle, they had to drive. The solution they eventually found was arguably even more insane than the A-40. Instead of putting wings on a tank, they decided to throw the tank out of a cargo plane and use rockets to stop it from smashing into the ground. This led to the development of the BMD series, the Boyeva Mashina Desanta, the airborne combat vehicle. These were fully tracked amphibious tanks made of aluminum alloy. To deliver them, the Soviets developed a retro-rocket parachute system. The tank would be dropped from an immense Antonov AN-12 transport plane, the spiritual grandson of the weak TB-3 that failed to tow the A-40. As the tank fell under massive parachutes, a sensor probe would dangle below the tracks. The moment the probe touched the ground, it would trigger a bank of solid-fuel rockets strapped to the tank. These rockets would fire instantly, creating a massive blast of reverse thrust that brought the tank to a virtual halt just 1 meter above the ground, allowing for a soft landing. This system, known as Ryakta, was a triumph of engineering. But there was one final hurdle. The Soviet commanders wanted the crew to drop inside the tank. They wanted the vehicle to hit the ground and immediately open fire, just like Antonov had envisioned in 1942. In a legendary display of Soviet bravado that rivals the flight of the A-40, the commander of the airborne forces, General Vasily Margalevich, insisted that this system be tested with humans inside. To prove his absolute confidence in the technology, he didn't send a random test subject. He sent his own son. In 1973, Alexander Margalevich sat inside a BMD tank packed with pressure sensors, strapped into a specially designed shock-absorbing seat looking like an astronaut. The tank was pushed out of an aircraft thousands of meters above the Earth. As it plummeted, the parachutes deployed, and seconds before impact, the retro-rockets fired in a blinding flash of fire and smoke. The tank landed gently.
Alexander Margalevich unhooked his harness, started the engine, and drove away. The dream of the A-40 had finally been realized. It took 30 years, the invention of jet transport planes, and the development of space-age rocketry, but the Soviets had finally figured out how to make a tank fly. The lineage is clear. The Antonov A-40 was the crude wooden ancestor of the sophisticated airborne armor of the Cold War. It was the first clumsy step in a journey that would eventually allow the Soviet Union to project armored power anywhere in the world within hours. The A-40 failed so that the BMD could succeed. The irony, of course, is that the solution wasn't to make the tank fly like a bird, as Antonov had tried. The solution was to let it fall like a stone, and then catch it at the very last second with an explosion. As we move to conclude the story of this bizarre machine, we must look at what remains of it today. In a world of digital archives and preserved museums, surely such a magnificent oddity is sitting in a hangar somewhere. The answer, unfortunately, adds a final layer of mystery to the tale of the flying tank.
If you were to visit the Kubinka Tank Museum outside of Moscow today, you would walk through hangars filled with the iron giants of the Eastern Front. You would see the T-34s that swarmed the German lines, the massive IS-2 Stalin tanks that crushed Berlin, and the terrifying German Tigers captured in battle. But if you look for the Antonov A-40, you will find nothing but empty space. There is no surviving prototype. There are no rusted wing spars tucked away in a dusty corner. The only physical evidence that this machine ever existed resides in a handful of grainy, black and white photographs and a few folders of declassified documents in the Russian military archives. The fate of the single A-40 prototype is a testament to the brutal pragmatism of the Soviet war effort. After the cancellation of the project in February 1943, the machine ceased to be a unique aeronautical experiment and instantly reverted to being strategic material. The T-60 tank, which had been stripped of its fenders, radio, and gun mechanism, was almost certainly re-equipped and sent directly to the front lines. In the meat grinder of 1943, the Red Army needed every hull it could get. It is highly probable that the very tank Sergei Anokhin landed so gracefully in that field was destroyed by a German anti-tank shell weeks or months later, its crew unaware that their vehicle had once touched the clouds. As for the massive biplane wings, their fate was likely even more mundane. In the freezing Russian winter, wood was a precious commodity. The complex lattice of pine and plywood that had been engineered to lift 6 tons was likely dismantled and burned in cast iron stoves to keep mechanics warm, or scavenged to repair other gliders and aircraft. The flying tank didn't end up in a museum. It ended up as smoke and scrap metal. For decades after the war, the A-40 existed in the West as little more than a rumor. When early intelligence reports and sketches surfaced, Western aviation experts dismissed them as propaganda or fantasy. The idea seemed too absurd, too cartoonish to be real. It wasn't until the fall of the Soviet Union and the opening of the archives that the full story was confirmed. The blueprints, the flight logs of the TB-3, and Anokhin's after-action reports proved that the Soviets had not only thought of it, they had actually done it. However, the legacy of the A-40 extends far beyond its physical disappearance. It occupies a critical place in the biography of its creator, Oleg Antonov. In 1942, Antonov was a talented but relatively obscure designer of gliders. The failure of the A-40 could have ended his career. In Stalin's Russia, failure was often interpreted as sabotage, and designers who wasted resources on useless toys often found themselves in the gulag. But Antonov survived. The boldness of the A-40 design impressed his superiors. They saw a man who was unafraid to tackle the problem of heavy-lift transport, a problem that would define the rest of the Soviet century. There is a profound historical irony in the career of Oleg Antonov. The man who failed to make a small 6-ton tank fly would eventually go on to found the Antonov Design Bureau, which became the undisputed king of aerial giants. Decades later, his bureau would produce the AN-22 Anti-A, the AN-124 Ruslan, and the crowning glory of aviation, the AN-225 Maria, the heaviest aircraft ever built. When you look at the AN-225 Maria, capable of carrying a space shuttle or a payload of 250 tons, you are looking at the spiritual successor of the A-40. The lesson Antonov learned in 1942 was that you cannot simply strap wings to a heavy object. You must build an aircraft that can swallow the object whole. The flying tank didn't die, it evolved. It stopped being a tank with wings and became a plane with a cargo hold big enough to carry an entire tank platoon. The DNA of the clumsy wooden A-40 is present in every massive cargo lifter that flies today. The story of the A-40 also serves as a fascinating case study in the psychology of wartime innovation. It represents a specific category of weapon, the desperation weapon. Much like the Japanese kamikaze aircraft or the German V-2 rockets, the flying tank was a solution born from a cornered animal. When a nation is fighting for its very existence, the filter for bad ideas disappears. The boundaries of physics and logic are pushed until they break. Usually, these desperation projects fail. They consume resources that could be better spent on conventional weapons. But occasionally, they shatter the ceiling of what is possible. The A-40 failed as a weapon, but as an engineering feat, it was a triumph. It proved that armor and flight were not mutually exclusive concepts. It broke a psychological barrier. Before the A-40, the tank was an earthbound creature, mudbound and heavy. After the A-40, the tank was merely a payload waiting for a powerful enough engine. Today, the concept of air mechanization is a standard part of military doctrine. The United States uses C-130 and C-17 transport planes to execute LAPES drops, where armored vehicles are pulled out of the back of flying aircraft on sleds. While they don't have detachable biplane wings, the spirit is identical to Antonov vision, getting heavy metal to the fight faster than the enemy expects. As we look back at the grainy footage of World War II, it is easy to focus on the industrial slaughter, the millions of shells fired, the cities leveled. But stories like the A-40 remind us of the human element behind the machines. They remind us of the engineers drawing feverishly by candlelight in freezing workshops. They remind us of pilots like Sergei Anokhin, who climbed into a steel box with no parachute, knowing he was about to defy the laws of nature simply because his country asked him to. The Antonov A-40 was a glorious failure. It was a machine that shouldn't have worked, designed to solve a problem that couldn't be solved, flown by a pilot who refused to be grounded. It remains one of the most compelling what-ifs of military history. What if the Soviets had the PE-8 bombers to tow it? What if a fleet of flying tanks had descended upon the German rear guard in 1943? We will never know. But somewhere in the infinite archives of history, there is a sky where the engines of a TB-3 are roaring, a steel cable is pulling tight, and a tank is rising into the air, its wooden wings catching the wind and casting a shadow that no enemy soldier ever expected to see.